Hello everyone, it's Mr. Wolfe here, and in this video I'm going to be walking through Level 2, Scenario 2. So Miss Ruta is reorganizing her closet and applies a force to lift Box A and Box B to the top shelf. She does more work on Box B. So really quick, I'm just going to label this Box A, Box B. It says she does more work, so I'm just going to draw a bigger W here, a smaller W here. Just kind of visually helps me, but to the same height. So if that's the case, maybe I'll just draw kind of like height here. Heights are the same. Assume both boxes are at rest on the ground and at rest on the top of the shelf, and we're going to ignore air resistance. So the question is, how do the masses of box A compare to the mass of box B? Okay, so how do their masses compare? Well, in order to solve this, what we need to do is draw our LOLs. And so you guys sometimes, I think, can just start kind of drawing and kind of think through it. But I like to kind of go back and forth between the explanation and the LOLs to show you how your explanation really supports your LOL. It's this thinking process that allows you to make these LOLs. And a lot of you guys are able to actually do this thinking. It's just sometimes I think it's putting it into words is the difficult part, and it just takes practice. So that's what we're doing now. Both boxes start at rest, so if that's the case, then there's no K. So we just draw no K here for the initial scenarios. Both boxes have no height, so if that's the case, then there's no potential energy, right? So no potential energy, no potential energy. All right. It's box B experiences more work, right? And this is a little tough because it's like, okay, so what does that mean? Well, that is the model right there. A lot of times it's like there's some information that allows us to know what energy is, and in this case, it's just telling us that box B has more work. So that's all we need to have here. There's really no need for a physics concept. So then, if that's the case, no work, well then, oh sorry, box B experiences more work. So if that's the case, I want to draw more work going in. So I'm going to draw an arrow, and maybe draw 4 blocks right here, and maybe we draw 2 blocks right here. I'm going to say work, work, and then again, what was it caused by? Caused by the force of push, and here caused by the same force, push. All right. So because box B experiences more work, well then we know that it has to have more UG, right? And less UG here. So because box B experiences more work, box B has more UG, or has greater UG. All right. So now we know how their potential energies compare. All right. More for box B. But the question's not asking about potential energy, it's asking about the mass of the boxes, right? And in order to figure this out, we're going to use the equation UG is equal to MGH to kind of reason through this. And we could use this template for our concluding statement. So I always like to start off with, well, what's constant? All right. And if I look here, let's see. If I go back up here, it looks like the height's constant, right? And is that part of my potential energy equation? Absolutely. So I'm going to draw height being the same for both of these. All right, so height is constant, or the same, right? I could always just say the same. But I could also say constant. Either of those works. Could also say constant. So height is constant. So now I want to see what other variable is changing. Mass could be different, but again, I'm trying to figure that out. So I don't know about mass, but UG, we just figured out that box B has more UG, right? So I'm going to draw a bigger UG here and a smaller UG here. Again, they're going to have the same G because they're both on Earth. But if this box is going to have way more potential energy, well, the only other variable that could change here would be mass. Right? And if this is going to have a smaller UG, well, then that means the only variable that could be different is the mass. So to kind of write this out, if height's constant, or height is constant, so if UG increases, then my mass has to increase at the end of the day as well. So in this case, it looks like box B, because that's what we're talking about right here, box B has more mass in this case. Thanks for watching.